Alright, so today we're going to talk about the distributive property. And we've worked on the distributive property on our math review. And I'm going to start off with problem 2 times x plus 1. And mathematically what we do on our math review is we look at our parentheses. This is our group, because parentheses are a grouping symbol. So we have a group of x plus 1. And I can't simplify inside. But on the outside, I have 2 of them. That tells me how many we have. So algebraically, we would multiply 2 by everybody inside the parentheses. And we would get 2x, because 2 times x is 2x. And then we would get 2, because 2 times 1 is 2. So I should have 2x plus 2. And I wanted to model that with the algebra tiles because you're going to see it on the STAR test modeled as algebra tiles. And what does that look like? Well, the first thing we're going to do is we're going to start off with our parentheses, x plus 1. And they generally put a circle around it to indicate that it's grouped together. Okay, and then I have 2 of them. So then I need 2 groups of x plus 1. And then they'll put a little circle around it to indicate that's a group. So these are grouped together inside the circle, and these are grouped together inside the circle. And we have x plus 1 and another one, because we have 2 of them, x plus 1. And then I can put them together and combine them. And I do get 2 x's and 2 constants. So that's the model. Let's look at another example. Now I'm going to have negative 3 times x minus 2. So in this case, I'm going to model first. So I'm going to have x and then minus 2. So there's my group. And then I need to build negative 3 more. Okay, well, I'm going to ignore the negative at the moment. So I'm going to build 3 more. So here's another x minus 2. Here's another x minus 2. So now I have those 3 groups of x minus 2. Now, I'm going to deal with the negative piece, because that negative tells me to take the opposite. Okay, well, the opposite of a positive one is negative, so I'm going to flip the tile over to make it negative. And these negatives, the opposite would be to make them positive. So I'm going to flip the signs. I'm going to flip the opposite sign. So if it was positive, now it's negative, and if it's negative, now it's positive. And now I do that for each set. And then I can combine my like terms. So I have negative 3 x's, and I have 6 constants when I combine them. Now let's check it algebraically, because I would take negative 3 and multiply it to x, and then I would take negative 3 and multiply it to 2x. So negative 3 times x is negative 3x. Negative 3 times negative 2, which is a double negative, turns it into a positive 6. Another way to look at it is we have negative 3 times negative 2. What's the opposite of negative 3 times 2, which is positive 6. Now if we look back at our tiles, I have 1, 2, 3 negative ones, because the red ones indicate negative. And I have 6 positive constants, which are indicated by this gold side. So we do have the correct model for the problem. Okay, let's try one more. I want to model and scribe negative 2 times 3x minus 1. So if I model, I'm going to have 3x, and this gets a little, let's see, 3 x's and a negative 1, and that's one group. And then if I look outside the parentheses, I have negative 2 groups. Okay, again, I'm going to make it 2 groups at the moment, and then I'll deal with the negative. So I have another group of 3 x and a negative 1. So there's my 2 groups. Now to work with the negative, that negative really means to take the opposite of. So if I have groups of 3x minus 1, 2 groups of 3x minus 1, and I need to do the opposite, then I need to flip them over. So I'm going to flip over all of my tiles. So the green ones are now red, and the red ones are now the gold color. Flip it over. And now I have my negative groups, my negative 2 groups of 3x minus 1. Then I can combine them, and I have negative 6 plus 2 constants. So let's double check when we multiply it out. When we do our algorithm, I'm going to take negative 2 times 3x. That does give me negative 6x. Negative 2 times negative 1. That does give me a positive 2. And that does match what I have here. I have negative 6x's because they're red, and I have 2 positive constants. Now, how do we use this in an equation? Let me set that up. Now I have an equation set up, 6 equals negative 3x plus 2, and I'm going to model that on this side. My vertical line is a equal sign, so I'm going to have 6 positives, constants on the left side to match my equation, and I'm going to have 3 negative x's, so those are going to be the red ones. There's 3 of them, and then I have another positive 2 constants. Okay, so there's the model. And I just realized I messed it up. It should be negative 3 times x plus 2, which means to fix it, this is one set of the distributive property. Here's the second set, and here's the third set, and these would be circled to indicate the sets. Now, this is 3 sets of x plus 2. There's the 3. Now I need to address the negative piece of it, so I need to flip my pieces over. So they were all positive, now they're all negative. Then I want to combine like terms. So now I want to combine them. So I have negative 3x's, and I have negative 6 pieces. And let me do that distributive piece on the equation part. So I'm going to multiply by negative 3. So I get 6 equals negative 3x minus 6. So that does match what I have modeled here. Okay, then I need to isolate my x terms. So I need to get these negative 3x's by themselves. They are subtracted by 6 constants. That means I need to add 6 constants for the inverse operation. So I need to add 6 constants. And whatever I do on one side, we do on the other. So I need to add 6 constants to the other side. Unfortunately, I have run out of tiles. So let me 0 pair these out, and then I can borrow it over here. So that goes to a 0. These 2 pair up and go to a 0. These 2 pair up and go to a 0, and there's my 6. These 3 negatives paired with these 3 positives, though they add up to 0 and 0 out. So that's how I'm able to get those off of that side. I've added 6 to both sides. Equation-wise, what that looks like is I would add 6 to both sides. That would 0 out, make that a 0. 6 plus 6 would combine to be 12, and that equals negative 3x. So now I need to isolate my x's even further. I have 3 of them. I need to know what 1x is. So if I separate them into groups, I want to group my 12 pieces that I have here into the 3 x's evenly. So let me divide them up. Looks like it can fit more in there. Okay, and I can get 4 constants into each x. Okay, now the thing is that this is a negative x, and I need a positive x. So just like we did before with the negative, I need to flip it. So if it's negative, I need to make it positive. And if I flip this one, I have to flip all of them. So everyone gets flipped. So now I know what the positive x is. The positive x is equal to negative 4. Because I'm dividing it out, I only need to know what one of the x's are. So one of the x's is negative 4. And now how does that look on the equation side? I'm going to divide by negative 3 on both sides. Negative 3 divided by negative 3 makes a 1. So I'm going to cross through it, making a 1. That leaves me a single x. And now I'm left with negative 4. So 1x is negative 4 pieces. Okay, we have one more example to look at. Let me clear the board. All right, for our last example, I'm not going to be able to use the tiles. I simply just do not have enough to model. And we're going to move away from those anyway, but they needed to know what that's going to look like modeled as the star. So when I'm looking at the equation, I'm looking at my parentheses first because that's my group. And I look inside. I cannot simplify inside, so I turn my attention to that negative 3. That means I have negative 3 groups of these, which means I'm going to distribute. So I am going to multiply everybody inside the parentheses by negative 3. Negative 3 times 4 is negative 12r. Negative 3 times negative 8, that is a positive 24. You can look at it two ways. You can look at it, a negative times a negative is a positive, or you can look at it the opposite of the negative. The opposite of the negative is a positive. Then I bring down the negative 36. I want to isolate my r variable, which means I need to move the positive 24 by using inverse operations. The inverse operation is going to be to subtract 24 from both sides. That zeroes it out. I'm going to bring down my negative 12r. That's going to equal negative 60 when I add them together and combine those terms. Then to further isolate the r, now I have a negative 12 multiplied to it. The inverse operation of multiplication is division, so I'm going to divide by negative 12. What I do on one side, I have to do on the other. That changes to a 1. So I'm left with a single r isolated all by itself. Negative 60 divided by negative 12 is positive 5. Again, you've got that double negative, or you have the opposite of the negative. 60 divided by 12 is 5. And that would be our solution. Okay? Now it's your turn to practice.